Hello everyone, hope you all are doing great. And in this video or in this video series, we are going to be kicking off a new course, and this one is going to be on UIKit. And in this video course, we are going to be creating this Run Awesome app. Now, this is sort of like a clone of Runtastic with slight variations in UI, but essentially what you're seeing here is a map, and this map is gonna show users location, and this is basically like where they are, where they can start their run and everything. And you've got two different tabs. There's a history tab that actually stores and keeps the history of all the run, that's why run logs, and the actual run tab itself, where you can see where you are in the map. This is a fully interactive map, and it's centered on the user's location. And then you can also start a run. As soon as you click on start run, you basically jump into this running screen, which is basically going to show you your running stats. So you're going to see how long you've been running for, the average pace per mile, and the total distance that you have covered so far. And if you notice, initially when we launched this, this actually showed you that you can basically slide this around. So you're going to be building out this slider that actually is going to be used to stop the run. So in case you're running and you by mistake tapped on the stop button, that's why we are not going to create a traditional stop button. We are going to rather create slide to stop button. So you're going to basically slide and your run is going to be ended. Okay, and your latest run is going to be logged in the run log screen, and as soon as you tap on it, you'll basically see how long and what path you ran at that time. So you can actually see where you started and where you finished. Okay, there's also going to be a challenge. So you're going to see we are storing a lot of information about the run itself, miles and everything, and when we are displaying in the map, you are displaying just the points. So the challenge is going to be basically displaying an overlay down here to put the other information in place as well. So that's going to be a challenge for you. But yeah, so this app we're going to be building from scratch everything, and you are going to learn a whole bunch of things, including the use of map and CL location. We're going to be using Realm database to store this these run logs, and you're going to be basically creating custom UI for reusable purposes, animations, and you're gonna learn to use Cocoa Pods and stuff for the pod dependency integrations. All right, so there's a lot to do, and we don't want to delay this too much, so let's go ahead and hop on and learn about this Run Awesome app. Alright, so let's go ahead and get started. Let's fire up the Xcode and start a new project. So just go to File, New Project, and you're gonna land us on this screen. We're gonna choose iOS template, select App, click Next. We're gonna name this app Run Awesome. Okay, and fill out the team if you have, organization identifier, something unique, so that becomes your bundle identifier. In my case, it's going to be com.devdecky.runawesome. We're going to choose interface as Swift, as a storyboard, not Swift UI, so make sure of that. And lifecycle is going to be UIKit app delegate, leave core data and test unchecked, and click next to create your project. Alright, so next you're gonna see your create project screen, and you want to make sure you select the right folder and go ahead and create that, and your project is gonna be created. Okay, let me resize the window. Alright, perfect. Okay, so a few things that we're going to do. First of all, we are going to remove the main.storyboard and view controller because we want to create everything programmatically, so we're not going to be using storyboards. So just move to trash. Okay, and I'm going to create a folder, a new group here, and I'm going to call this app stuff. Okay, anything related to app is gonna go in there, and I'm gonna move all these things inside this folder just to clean it up a bit. Okay, all right, next thing, we're gonna go into the info.plist, and there is a main storyboard file name. We're gonna remove that, so just click on minus to remove that. And for the application scene manifest, let's check out scene configuration. You're gonna find the storyboard name main. We're gonna remove that as well. Okay, and those are the two places where we need to remove the name of the name for, like, the main.storyboard reference. And then go to your project and go to build settings and search for run awesome. Okay, now there are a few things that have happened since we moved our info.plist inside this new folder. If you notice, our info.plist is still referred as run awesome /plist. So Xcode is not going to be able to find it, so we want to modify that. So I'm going to add app stuff folder right there. Okay, and just make sure if there is anything else. So headers is okay, private headers is okay. So yeah, everything else looks good. So with that change, I'm going to select and just give it a build. If you're not going to run, just build to make sure the build succeeds. So build succeeded, that's good. Now next comes basically the creation of some of the folders. So I'm going to quickly create a new group right here, and this group is going to be called helpers. Okay, and another group for our views, common views that we're going to create, and there's going to be a group for view controllers. All right, so these are going to be the views that we're going to folders that we're going to be using for the folder structure. Now we're going to start by creating a new file into our view controller, and let's create something called base view controller. Okay, and this is going to be base view controller. So by the way, I selected Cocoa-Touch class and then called base view controller, and we're gonna click next and gonna create that file. Okay, now one thing I'm going to do in this file is I'm going to say view dot background color is white, just to see if our view actually is launched properly. Okay, all right, so because we are doing programmatic view controller initialization. Okay, next thing, we're gonna go into scene.swift, scene delegate.swift file. Okay, and this function right here where your scenes are connected, you have this guard statement that is currently ignoring the window scene. So we're gonna simply change this underscore into window scene. Okay, and then we are going to create a window object, UI window, or we already have a window, so let's use that. So window is equal to UI window. All right, and what we want to create the window from the window scene. Okay, so we're gonna supply the window scene that we just extracted out here in the guard statement from the scene. All right, next we are going to create some temp code because we want to come back and create our tab bar and stuff, but before that we want to make sure our app is launching properly or not. So what I'm going to do is I'm going to create some temp code to make sure, like, our window is set up correctly and is being launched, and then we're going to come back and create our tab bar views and stuff like that. Okay, so what we're going to do is I'm just going to mark it temp code because we want to refactor it, and we want to create VC base view controller. Okay, and then we want to have our window. Okay, so we want to have our window, and we're going to say window.root view controller, and we're going to assign VC to this. Okay, and we're going to say self. We already have our window assigned, so let's do this. Let's create a new window instance, so I don't have to do this, and we're going to say self.window is equal to window. Okay, so they're gonna reference the same thing, and then we're gonna say self.window dot window dot make key and visible. Okay, so that is going to make sure that our base view controller is the first view controller that is launched. I'm gonna change the simulator to iPhone 12 Pro Max. All right, and just give it a go. All right, so it's gonna launch in a minute, so let's give it a bit time. All right, so the simulator did launch, and there we go. This is our screen. Now, to make sure that this is our screen, we want to change this to orange. I'm gonna add the alpha component in here, and then we're gonna see, there we go. So this is basically our base view controller. All right, so you, in this video, you were you basically did a few things. You structured your code like, you know, in folders, and we also created our base view controller where we're gonna define some of the common properties, and all the other view controllers are basically gonna inherit from this. So you set up that, and you also made sure that you are launching your view controller programmatically. Okay, so once again, this whole course is gonna focus on programmatic UI, and every thing that we're gonna create is gonna be in the code. So no use of storyboard and no use of nib or zip files. All right, with that, I guess it's a good break. So in the next video, we're gonna create our tab bar, so we can set up our tabs, and we're gonna change this or remove this temp code and change it to have the tab bar basically have the tab bar replace this, so we can launch tab bar controller instead of just the view controller in this place as a first screen. Okay, so I'll see you guys in next video. Alright, so in this video we're going to be creating our tab bar controller. So the best way to create a tab bar controller is to basically have its own class that can actually basically contain all the code of tab bar creation and view controller setup. So what we're going to do is we're going to go into our helpers, and I'm going to create a new file, and we're going to touch Cocoa Touch class, or we're going to select Cocoa Touch class, and we're going to call this one tab bar. Okay, and this is going to inherit from tab UI tab bar controller. Okay, so yeah, we can call it tab bar view controller. Yeah, there you go, that's fine. Okay, so we need so tab bar controller basically contains all the tabs that are going to be shown in those tabs. So in order to get ourselves set up, there are a few things that we're going to do. First of all, we need a tab bar tint color, so we're gonna simply say tab bar, and tab bar property is created within tab bar controller. So if you go jump into definition, you're gonna find that there is a tab bar open property that is created, and you can actually set some of the properties for that. So for example, tab bar dot tint color you can define, and we're gonna say UI color dot label is what we want, and then we want to call a function that's gonna set up view controllers for us. So we're gonna say set up view controllers, and this function does not exist here, so let's go ahead and create that. Before we do, we want to make this class final, so it can speed up our compilation process, and we can indicate our compiler that this class is not going to have any further inheritance, so you can treat this as a final class. This helps in dynamic dispatch for the method and function calls. Okay, so what we're going to do is we're going to create a private function. We don't want to expose this to other classes, and here we're going to basically have view controllers. Now view controllers is another property that's part of the UI tab bar controller. That's why we actually inherited from here. So view controllers is basically an array of UI view controllers, all the view controllers that are gonna take or that are gonna have tab within the tab bar. Okay, so to start off, we're gonna have an empty array. Okay, and that is going to be our view controller. Then we're going to have another private function, create view controllers. Okay, and this function is going to basically help us set up the icon for the tab, and icon symbol, selected icon, and basically tab bar item and stuff like that. So that's why we are creating this. So you can think of this as a convenience function. So we're gonna say for view controller, UI view controller, and we're gonna ask for title, what the title for this tab is going to be, and what's the system image, the icon basically that you want to use from the system image, and this is going to return a UI view controller for us. Okay, and what we're going to do here is first we're going to create icon symbol. Okay, and we're going to say icon symbol is going to be UI image, system name, and we're going to use the system name that's being supplied to us, or system image that's being supplied to us as a string. Okay, so that's going to be basically the icon symbol, the symbol that is going to be visible when it's not selected. When it is selected, we're gonna display selected symbol. Okay, and we're gonna once again create a UI image, and this time we're gonna choose the one that takes the system name and configuration. So system name with configuration. Okay, and this is going to be basically system image. Okay, and with configuration is going to be UI image dot symbol configuration. So we want to have symbol configuration, and what we are looking for is the weight. So we want to make this font, this image, bold. So we want to say we want to have bold symbol. Okay, when it is selected. Now next item, we're going to create a tab bar item, UI tab bar item, and UI tab bar item takes title, image, selected image. So we want to select that. So title, image, and selected image. Title is going to be the title that we have been passed in, and image is going to be the icon symbol. Selected image is going to be selected symbol. And then for the view controller, we're going to say view controller that's being passed in to us dot tab bar item is equal to tab bar item that we have created right here. Okay, and we want to return this view controller like so. All right, so now in order to add this, add some of the view controllers to this, we're going to create a couple of them. So we're going to need one for home. So we're gonna say home view controller. This is gonna come from UI view controller. Okay, gonna inherit from UI view controller, and I'm gonna change this to basically inherit from base view controller. And for now, we're gonna say background color. For example, this one is gonna have maybe orange, and we're gonna create another one that is going to be a history view controller, which is gonna show the run history. So history view controller, and once again, it's gonna come from base view controller. Remove all the commented code, and v dot background color is dot blue. Okay, just to create a distinction between those two. And I'm gonna come here and remove this guy right here. Okay, go back to your helper tab bar view controller, and here we're gonna create two view controllers. So we're gonna say create view controller for, so for is gonna, first one is gonna be home view controller, title is gonna be run, and the system image, we're gonna use hair, and I'm gonna say run like that. Okay, so that's gonna be the first one. And create view controller, we're gonna use history and create a history view controller, and this one I'm gonna say run logs maybe, or just logs. Okay, for the system image, we're gonna use clock. Okay, all right, see these names, these system names are coming from SF symbol. So if you open your SF symbol app in your Mac, and you look for hair, you're gonna find these symbols created there. So now we have our tab bar ready to go. Now what we're gonna do is we're gonna go back to our scene delegate, and I'm gonna remove this whole temp code. Gonna recreate this. Okay, so we're gonna have our home is gonna be tab bar view controller. Okay, and this tab bar view controller is basically our tab bar view controller right here, right? So that is gonna be the instance of that, and we're gonna say window dot root view controller is gonna be the home, and then we're gonna say self dot window is equal to window that we created, and window dot make key and visible, like so. Okay, so let's go ahead and launch this, and there we go. We have our tab bar created, and as you can see, the symbol that we provided created these two tabs with the image, hair, and clock. So these are going to be our view controllers that we're going to be using and populating with, like, their own views and stuff. But yeah, so this is how you can create a tab bar view controller within your app programmatically. Now coming down to the next video, what we're gonna do is we're gonna create some helper views. So we're gonna need basically a gradient view, which is gonna become the background for our view controllers, and we're gonna basically set that gradient view inside our base view controller. So every view controller that's inheriting from that just gets that background view, and then we're gonna start designing our home view controller. Okay, so that's how we're gonna proceed. All right, so I'll see you guys in the next video. All right, welcome back, and in this video we're going to be creating our background view, the gradient view. So let's go ahead and create a new file inside our views, and I'm going to select a Swift file this time, and we're gonna name this one gradient view. Okay, and this is going to import from UIKit, and we're going to create a final class gradient view, UI view. Okay, and now what we're gonna do is we're gonna override the layer class to use CA gradient layer. So we're gonna simply say layer class Okay, and we're gonna override with CA gradient layer dot class for coder. Okay, and for the initialization code, we're gonna have our own initializer that will take colors, an array of UI color. Okay, and we're gonna call super.init first with frame 0, and then we're gonna say the gonna create a gradient layer. So gradient layer as CA gradient layer, and then we're gonna say gradient layer dot colors is equal to colors dot map. So gradient layer dot color expects us to pass an array of CG colors. So what we're gonna do is we're gonna use the map operator to convert all these colors, UI colors, into CG colors, like so. Okay, and then for the start point, I'm gonna use CG point from the top left. That's gonna be 0 0 to end point is gonna be CG point 1 1. That is bottom right. Okay, so imagine this is your phone screen. This is gonna be the top left and bottom right. So 1 1 and 0 0. So it's gonna go all the way. Okay. All right, so it's asking us to create required initializer, so we're gonna create that, and there we go. This is the whole code for our gradient layer. Now this gives us a flexibility not to create, not to have basically an image to be used as a background, and our view is going to be much more flexible in terms of, like, taking over the entire screen, the resolutions and stuff like that. Okay, so what we're going to do is we're going to go into our base view controller now, and inside our base view controller we want to create a background layer. So I'm going to create a private lazy var background layer, and this is going to be a gradient view, and we're going to create view gradient view with colors. So we want to actually take a set of colors, so go ahead and choose your colors. What I'm going to do is I'm going to paste these colors that I actually chose. It's sort of like a blue, and there's a light blue, and there's light purple and slightly dark purple. All right, so these are going to be our colors. I'm going to return V to remove this complaint like error, and we're gonna say translate auto resizing mask into constraint. We're gonna say false because we want to provide our own constraints. Okay, now I'm gonna create two functions. There's gonna be a setup views function and setup constraints function. So I'm gonna create these two private functions. Okay, all right. So first one is where we're gonna add our subviews, and we're gonna follow the same pattern where, like, for all the views or view controllers, whenever we are setting or adding UI component, we're gonna add those UI component inside set of views, and we're gonna set up constraints for individual UI elements. So this time we are setting background layer, so we're gonna say ns layout constraints dot activate, and you're gonna say the background layer is gonna be it's gonna have leading anchor constraint equal to view dot leading anchor, and what we're gonna do is we're gonna cover the entire screen with this background layer. So I'm gonna simply copy this and paste it a few times. So leading trailing top, bottom. Okay, so trailing top and bottom. There we go. All right, so these are all the constraints that are going to be that are going to make sure that our background layer is covering the entire screen. Okay, now when we go back into our home view controller, we're gonna remove this. Okay, and since it is inheriting from the base view controller, it should have that background, and I'm gonna do the same thing here. Okay, and then we're gonna just launch and see what we got so far. All right, so there we go. This is our gradient, and if you change tabs, you notice there is no difference because like, you know, both are using the same gradient. So once we start putting our UI elements into these individual view controllers, then we're gonna see more, like, you know, variations in these screens. Okay, so right now they look same, but soon they're gonna start looking different. All right, so this was our gradient view, and next we're gonna start setting up our home view controller, which is gonna basically host a map, a button for us to launch the run, and some of the top label stuff. Okay, and we also gonna create location manager, etc. into that space. Okay, so I will see you guys in next video. Thank you. All right, so before we start populating our home view controller, there are a couple of things that we need to create. So we need a view, a circular button view, which essentially is going to so let me show you what I'm talking about. So this guy right here, the run button, this is a circular button, and we can create one inside the home view control, or we can create a custom control. So let's create a custom control, because that way, like, you know, you will know how these custom controls are created, and it's going to be reusable for us. Okay, so I'm going to select a new Swift file here, and I'm going to say circular button. Okay, and we're gonna import from UIKit, final class, circular button, UI button. Okay, so this is gonna inherit from UI button, and we're gonna need a few properties that we're gonna ask our users of this control to supply to us. Okay, and those are going to be the border width, CG float, and if they don't supply, we're going to set it to 10 by default, and border color, which is going to be UI color, and we're going to set it to a default of white color. Now there are some properties that we're going to set. Title text, so whenever somebody is setting a title text, we're gonna put did set observer on this, and we're gonna call basically call set title. Okay, and we're gonna set the title text to that for the normal button state. Okay, and for title text color, this is going to be another property, UI color. We are simply going to call did set and set title color, title text color for normal state. Okay, all right, now for the initializer, we're gonna override this initializer super.init.frame. We're gonna supply that, and this is going to basically ask us to create this required initializer as well. and if there's anything that we need to do basically during the initialization, we can do it right here. But when we are done laying out our subviews, that's where we need to actually set up our corner radius and border color and stuff like that. So what I'm going to do is I'm going to say layout subviews. Whenever layout subviews is called super.layout subviews, finish whatever it is the superclass needs to do, and then call a function setup. Okay, and this is going to be a private function setup, which is going to help us set up our view. So we're going to say clip to bounds is equal to true, background color is equal to, so we're going to say purple is the background color that we are giving. So we are we are not providing flexibility. If you want to make your control more flexible, just take an input of that and then use that here, but I'm just gonna leave it as is. And for the corner radius, we're gonna say frame dot size dot width divide by 2. Now, this is the main reason why we are setting up inside layout subviews and not in init, because we are using auto layout. We want to wait for all the views to be laid out on the screen so the auto layout system can determine what their frame size is gonna be, and then we can get that information from frame.size to get the width, so we can actually create the corner radius divided by like half of the width basically. Okay, so all the frame related information in case of auto layout you only get after your views are laid out. If you do it like in init, what's going to happen is you're going to receive a 0 value for this if you're creating a 0 width frame, and we don't want to create a set width or set CG-rect frame, because we want to rely on auto layout to adjust according to the size of the phone's screen. Okay, hopefully that is clear why we are actually calling this setup inside layout subviews, not in init. And then we're gonna create our border color, and border color is going to be border color dot cg color, and border width is going to be the border width that's been set. Okay, with that, our circular button is ready to be used. Okay, now there is one more view that we need to create, or one more helper that we need to create, and that is a location manager. So I'm going to create our location manager here as well. So I'm going to select a sort file, location manager, and this is basically just to have a single class that can be initialized, so we don't have to set the accuracy and the activity type and stuff all over when we are creating our CL location manager. So I'm simply gonna first import from code location, create a final class location manager. And we're gonna create manager, which is gonna be of type CL location manager. During the initialization, we're gonna say manager is equal to CL location manager dot desired accuracy is gonna be KCL location accuracy best, because we are running, we need a best accuracy for that. And for the activity type, we're gonna say this is gonna be a fitness activity. As you can see, there are several other options available, and so the desired accuracy is going to be best, and the activity type is going to be fitness, because we are tracking a run. We are also going to create a function to check location authorization. So check location authorization, and this function is simply going to check if the location manager has the authorization status to be authorized when used or not. Okay, and if it does not, then it's simply gonna say manager.request when in use authorization. All right, so this is basically going to help us first of all create location manager, and then we can call this function anytime we need to check the authorization status. Now I'm creating this like as a class because that helps us basically set up these properties, and you don't have to initialize these properties again and again. On the contrary, you can just create like CL location manager inside your home view controller and stuff like that, and basically just set these other properties. But this is a little bit more reusable way of changing, because let's say if you want to change the activity type to support automotive, or automotive navigation, airborne, or any other option that you want to try on, then you can just do it at one place and just take the benefit of that change everywhere else. Okay, all right, so so in the next video we are gonna start working towards our home view controller. So we've got everything that we need in order to put together our home view controller, so we're gonna get started with that one. Okay, all right, so let's go ahead and work on our home view controller now. So open up your home view controller, and we're gonna create some UI elements at the top first. So I'm gonna create a mark, and I'm gonna say UI elements, and there's gonna be a mark for lifecycle. And in case you don't know, these marks actually appear as sections within your view controller. When you look at this breadcrumb control within Xcode, you can actually jump around. For example, we don't have much element right now, but I can actually jump around different sections. So I'll show you how you can get around once we have more content and we are scrolling back and forth okay, so first thing we're gonna do is we're gonna create our start button. So I'm gonna create private lazy bar start button, and this is gonna be our circular button that we created. Okay, and we are simply going to create a view circular button, and we are gonna return that view. First thing we're gonna set before we forget is to set the auto constraint to be false. Auto resizing mask into constraint to be false. Then I want to have border width, and I'll say border width is gonna be 15. Border color, we can use color literal in this case, and you can pick any color, for example maybe this kind of purple, but I'm gonna actually replace this with my project that I had. It's sort of like lighter shade of purple, so I'm gonna use that. Okay, you're gonna set the title text to be run, and we are also gonna add target. When user taps on it, we want something to happen, so we're gonna define that, and the target is gonna be on self. There is gonna be a selector, so I'm gonna just create an empty selector for now, and I'm gonna say touch up inside is gonna be the event when this is gonna get fired. I'm gonna create another section here, and I'm gonna call this helpers. Okay, and we're gonna create an Objective-C private func and this one is basically the selector that we're gonna call whenever this start run button is tapped upon. So I'm gonna call this start running. Okay, it's not gonna take anything, and we just gonna simply call that start running, like so. Okay, so that is our start button. Okay, then we are going to basically put a top label that's going to basically have the title for the page. So if we go back, this run awesome is basically the start. So I mean the title for the page. So you can use navigation view. I'm actually going to just use a simple label. So I'm gonna say private lazy bar top label UI label. And we're gonna set some properties. So we wanna set the text to be run awesome. We're gonna set the text alignment to be center, font to be 32 in size, text color to be dark gray. All right, yeah, I guess that'll do. Okay, next element we need is this map view, and we're gonna make this map view, but we're gonna make it a little bit like we're gonna set the transparency to, like, 0.6, so the background can basically we can see the background, and that's gonna give this like map a little bit like of this view, basically, like the gradient effect. Okay, so that's what we're gonna do. So you can say private lazy bar map view. Now for map view, we need to import mapkit. Okay, and we're gonna say mk map view. All right, and let's create our map view. And we're gonna once again translate this to false, because we wanna set the layout constraint ourselves using auto layout. We're gonna set the alpha value to be 0.6 and delegate to be on ourselves. So let's create an MD for extension, and we're gonna create an extension on home view controller, and we're gonna make this map view delegate. Okay, we're gonna make this view controller conform to mk map view delegate, because we're gonna be implementing view functions from this delegate. Okay, all right, so after that, let's go ahead and create an instance for our location manager. So local variables is the section name, and we're gonna say private var location manager, and we're gonna simply initialize this location manager right here. Okay, now inside the view did load, once again we're gonna call setup views, setup constraints. Okay, these two functions, so simply create them right here. Okay, so that's going to be basically our functions, and And then we're gonna call these. So we have already called this from view did load. Now we also want to check the authorization. So we're gonna say location manager dot check location authorization, because we want to launch that prompt that this app requires the access to the location. Okay, so that's one thing that we're gonna do in the setup view. We're also gonna add sub views to our view. First thing we're gonna add is gonna be top label. Then we're gonna add our map view and the start button. Okay, now we have added our views. Now it's time to set these basically views constraints. So first we're gonna have top label constraints. So and its layout constraint dot activate, and this takes an array, and this is where we're gonna basically define our constraints using anchor strategy. So leading anchor, trailing anchor, and stuff like that. So first thing, we're gonna set up top label, and top label is gonna have a leading anchor constrained to our view dot leading anchor, and we don't have any constraints, so I'm going to remove that, and I'm going to copy and paste this 4 times. Okay, so next is going to be trailing anchor, and we want this to be trailing anchor to the view itself, so pin it to the trailing of the view, and then top anchor. And this one I want to basically set this to the safe area layout guide. So I'm going to say safe area layout guide dot top anchor. So use safe area layout guide, which is right below this notch right here. If you set up this to view dot top area, then your run awesome is gonna basically be, so your constraint is going to start from here and your label is going to be somewhere around here. So that's what we don't want that, like, so we want like a little bit of a breathing room, so this don't run into the notch itself. And this plays well with the button based phones as well that have, like, you know, touch ID and stuff. Okay, so that's our top. Now we're gonna define the height for this guy, and I'm gonna say height is gonna be constraint equal to constant is the one that I'm gonna use as an overload, and I'm gonna say the height for this guy is gonna be 50 points. Okay, so that's our top label. Okay, and if I run this right now, okay, so this is awesome. We have few things going on here. We have a button visible here, like, you know, that button needs a location, so we can actually set that, and our map as well. But look at this, location, ns location when in use description is not added in info.plist. That's amazing. Like, you know, thank you Xcode for giving us this hint. We do need that permission from our user whenever we are asking for tracking their location. So I'm gonna simply copy that key and paste it and click enter, and this is gonna basically populate the right value. And this needs to be a description that can explain why you need this location permission. So this is basically explaining to the best of your possible, like, you know, in best words, like in a concise manner, like, you know, why you need users location. So we're gonna say need location to track run. Okay, that actually explains why do we need it. Simply save this and go ahead and give it another run, and there we go. So this is what we see. I'm gonna say allow. Okay, and that is allowed to see. But reason we actually launched this, so we can see, like, you know, that our label is label is located just fine, so like it is good. Now we're gonna constrain our map view. So minus layout constraint dot activate, and we are simply gonna add a map view, and a map view is gonna be pinned to the leading and trailing sides, but for the top it's gonna be pinned to the top label, and for the bottom it's gonna be to the bottom safe area layout guide. Okay, so constraint equal to view dot leading. Okay, once again copy and paste. Same thing is gonna go for trailing anchor. There you go, trailing anchor. There you go. Yeah, and for the top anchor we're gonna say top anchor, and this is gonna be top label dot bottom, and we're gonna space it by 8 points. Okay, and then for the bottom anchor we're gonna pin it to the safe area layout guides bottom anchor. Okay, so let's go ahead and give it a go, and what we should see is a map right there. So that is really that's really nice. Okay, so yeah, this is a fully interactive map, as you can see, and you can actually zoom in and out, and that's what we have right now. All right, so next thing, or the last view that we're gonna set the constraint to, is gonna be our start button, start run button. Okay, and it's gonna be an layout constraint dot activate, and right here we say start button dot width anchor dot constraint equal to. Okay, so we need to set this equal to constant. Okay, and this is going to be 100 points. All right, same goes for the height, because we want this to be a circle, so width and height are going to be same. And that way, like our corner radius is going to be width divided by 2, which is 50, and it's going to make a perfect circle. Okay, for the bottom anchor we're going to constrain this equal to view dot safe area layout guide dot bottom constraint, and we want to create a constant for -10. So we want to actually raise it up 10 points from the bottom, so we're going to use -10 for that. And for the X location, like for the view, we're going to say center to center X anchor equal to, and this is going to be view dot center X, so center it on the view in x-axis. Okay, so this is what we're gonna see as the run button be. Okay, all right, so there are a few more things we need to do. First thing we need to do is for our start run button, where did it go? Okay, we're gonna simply print right now start running. Okay, and for the home view controller, we need basically to show users location, but we need to wait until the map did finish loading. And if you remember, we actually added this view controller as the delegate for ourselves, so whenever the map is loaded we're gonna get that by calling or implementing map view did finish loading map. So as soon as the map is finished loading, we're gonna simply say map view dot show users location is equal to true, and we want our map to follow users location, so user tracking mode is gonna be follow. Okay, let's go ahead and give it a go one more time, and let's see what we see. So there we go. So as you can see, our user, our user is actually running right now on the street, and our map is constantly centered on the user's location, right? So that is what this gives us. Basically, this guy right here, show user location, shows the user location, and user tracking mode keeps it in the center of the screen. Okay. All right, with that, our home view controller is actually finished. It's not quite finished because we're gonna come back and bind this run button to our basically launch the current run view controller, but like, you know, as far as the UI goes, it's all complete. So in the next video, we're gonna basically create our current run view controller. Now current run view controller, I could tell you it's gonna be a big one. So because it's gonna have, like, you know, a lot of things in it, so we're gonna probably divide that into 2 videos, and then we have, like, you know, our history button and stuff coming up right after that. All right, so this is it for this video. Thanks again for watching. All right, so in this video we're going to be creating our current run view controller. So let's go ahead and get started. So I'm going to add a new view controller. I'm going to select CocoaTouch class, and we are going to name this current run view controller. Okay, and I'm going to create it. Okay, I'm going to remove all the commented code. Now this is going to be a bit long, so what I'm going to do is I'm going to divide this video into 2 parts. First part is going to be where we're going to create all the UI elements, and then after that we're going to basically set the constraints and basically set the timer and everything, because this view is also going to contain our custom slider, so gonna need some of the controls for that. Okay, so I'm gonna once again inherit from base view controller in order to take advantage of our gradient background, and I'm gonna create a mark for UI element. Oh yeah, I forgot to show you the, like, you know, why I actually create these marks. So now, like, you know, this view is a good size. So let me show you, like, you know, how the sections make difference. So for example, right now I'm in UI element. I can jump directly to local variables to see what all local variables I have, and I can directly jump into the extension part to see what all I have in the extension. So it sort of helps you, like, sort of divide your code if you are, like, you know, if you have a lot of code in your file. Okay, so we're gonna create a private static let title font size CG float. Okay, so this is going to be the title font size, and there's going to be one for a subtitle. So we're going to use these inside our view controller. So I'm just going to create 2 variables for that. Okay, and then we're going to have our top label. Once again, we're gonna set this to false. Now, if you don't know this, like, you know, why we are setting this false, if we don't do it, what is gonna happen is UIKit is going to try to constrain this according to the auto resizing mask, and your view is not gonna look basically, or constrain basically do the way you want it to. So in order to work with programmatic auto layout, you will you always have to make sure your control anything that is actually coming down from UI view. So if you go look at the hierarchy UI view, this is what UI label comes down from, and like, you know, if you look, if you have a UI view, let's see if we can drill down into a UI view or something. Okay, gradient view. Okay, so anything that's actually under responder chain, like, you know, for UI responder, all of them have to have, like, you know, this auto resizing mask into constraint set to be set as false before you can start using the auto layout based constraints. Okay, so hopefully that is clear why we are doing that. We're gonna set our text, and this time we're gonna change it to running. Text alignment, I'm gonna set it to center, and font is gonna be font dot width size, and I'm gonna take self with capital S dot title font size. Now difference between capital S and small s self is basically capital S self refers to the type, the small s refers to the instance. Now the difference between instance and type is type is your basically your class, no instance variable that is created, right? No object is directly referring to your type. So anything that you're creating static belongs to your type, and anything that you just create, for example, in this case, current, if you want to basically call this view did load for current view controller, the only way you can do that is by creating an object for this. So current view controller, if I create an object, this is how I'm creating an object. I'm gonna simply call vc dot view did load, right? So this is this view did load is part of the instance, and the instance that we have created is this object right here. Okay, but if I want to access this title font size, then all I have to do is say current run view controller dot title font. It's private, that's why it's not finding it, but yeah, let me change it. So there you go. So as you can see, like, you know, there's no instance that's being created, so it's actually part of the type itself. So anything that actually you want to share, you can have that defined as private static, and that's another way basically to create your objects if you want to have a shared object. And this is a common thing to do, creating static in case of singleton design pattern. Okay, all right, so let's see, we do want to define the text color as well. So I'm gonna say it's gonna be dark gray, and I guess so we have the text, we have the alignment, font, color. Okay, so I think we're good. All right, next is gonna be a time label. So let me go ahead and pull up the app one more time, and this is these are the labels that we are actually talking about. So this is the time label that we're gonna create, and then we're gonna create this average space label. We're gonna create a distance label, and this control that actually is gonna be used to yeah, essentially like dismiss. Okay, now as you notice, there's a bug. So in this branch there was a bug which we will fix like in future, and I'll show you, like, you know, how we can actually fix that. But anyways, it's actually working fine now. And also you see this this thing right here, we are not gonna create this because like earlier I thought like we'll actually have a button to center our map, but later on I dropped that idea because like we are following the user, so we don't need to center. The user is always going to be in the center of the map, so it's always going to follow, so we don't need to worry about that. Okay, once again we are going to be creating these three guys. So okay, we go to the home screen, and we are going to be first creating our time label. So private lazy var time label. All right, so let's return this view, translate to false. All right, and we need the text color. So text color is going to be white. We need font. So we're gonna take UI font dot bold for system font, and we're gonna once again use self dot subtitle font size. Okay, we dot text is going to be hour, minute, and second. Okay, so that is our time label. All right, next is going to be the pace title label. Okay, so where we're gonna have the pace listed. Average pace font is going to be v dot font dot width size self dot subtitle. So this one is not gonna be bold. Okay, and then we're gonna have our pace label. So this was the title. Next one is the actual label where we're gonna list the pace, the current pace. Okay, and we're gonna once again have these three things. So I'm gonna just copy this, and so we're gonna have text color as white. The text, I'm gonna give it 0, 0, 0. Okay, and for the font we're gonna have UI font dot bold system font self dot title font size. Okay, that's gonna be for the pace, and then we're gonna have a subtitle for pace, which is gonna show like per mile. So I'm gonna take this guy, and I'm gonna say pace subtitle label. Okay, and once again it's gonna be white, and this is gonna be per mile, and the font is gonna be subtitle font size. All right, next we're gonna create a stack view. So this stack view is how we're gonna keep all these pace related views together. So like that, UI stack view, and UI stack view we're gonna actually create an array of arranged views. We already know what those are gonna be, so we're gonna say title label is 1, pace label is another one, and base subtitle label is the third one. V dot translate is equal to false for this one too. Return V. Alignment is gonna be center. Axis is gonna be vertical, and distribution is going to be equal spacing. Okay, so that is our base stack view. All right, so we're gonna need similar for the distance. Okay, so for the distance, it's gonna be very similar. So what I'm gonna do is I'm gonna copy paste, and I'm gonna talk to you guys about it. So we're gonna have distance label, which is gonna have distance. We're gonna have distance title label, then distance label, like how much distance you have you ran so far, and then subtitle for the miles, however many miles, and then the stack view that's actually going to contain all these three values together. Okay, and then we're gonna have basically our page stack view. Now page stack view is the stack view that's gonna contain basically all three: the time label that we have created, the base stack view that we have created, and the distance stack view that we have created. So all three of them are gonna go inside another stack view. So private lazy var page stack view, UI stack view. Okay, and UI stack view, basically the arrange views. Arrange views are going to be title label, time label. Then you're going to have your base stack view and distance stack view. Okay, we're going to return this view, and we're going to set its translation to be false, so we can create our own constraints. And then we're gonna have our alignment, which is gonna be center. Axis is gonna be vertical. Distribution is going to be equal centering. And we're gonna also create a background color for this. So we're gonna define a background color, which is gonna be UI color dot black dot with alpha component, and we're gonna say it's gonna be 0.2. So it's like slightly tinted sort of a color. Okay, now next we're gonna create three views. This is gonna be basically for that slider control. So first one is gonna be a capsule view. Okay, and this is gonna be a UI view. And this is gonna have a background color of UI color dot black dot with opacity or with alpha component of 0.5, so slightly darker than the background. And we're gonna have layer dot corner radius to be 35, and v dot layer dot masks to bounce to be true. Okay, so we're gonna make it like look like a capsule, and we forgot to put var in there, so there we go. All right, next one is gonna be the knob, the slider knob. Okay, so we're gonna call this stop slider knob, the one that you're gonna slide, and this is gonna be UI image view. Okay, and we're gonna create our UI image view. We're gonna return that view, Okay, now we're going to make sure that this is user interaction is enabled for this one, because we are going to be interacting with this guy. And then for the image, we're gonna say it's gonna be UI image system name, and we're gonna use dot arrow triangle dot up dot right dot down dot left dot circle. Okay, and this is once again coming from SF symbol. I'm gonna have a white color for the tint color, and we're gonna have layer properties. So I'm gonna copy the layer because we're gonna need that. Border color is going to be UI color dot white dot CG color. Border width is going to be 5. Corner radius is going to be 25. Masks to bounds is gonna be true. Okay, all right, so that is our slider knob. And then we're gonna have another image view for slider stop. Okay, so this slider stop, what this is gonna do is we're gonna do some computation, and whenever our knob reaches the slider stop center, or it crosses that, that's when we would know that we have to stop running and return to the main home screen. Okay, so basically end run and dismiss the view controller, current run view controller. Okay, so we're gonna say translate is equal to false. Image is UI image system name, and we're gonna have stop dot circle dot fill. Tint color is gonna be white. Dot border color is going to be UI color dot clear dot width alpha component 0.5 dot CG color. Border width is going to be 5. Border radius, corner radius is going to be 35. Mask to bounds is going to be true. All right, so let's go ahead and build. Everything should build, although we are not going to be able to launch this current view controller yet because we haven't created everything that we need. So I guess in the next video we're gonna create our local variable, the life cycles of the helper functions, to make this view functional. Okay, all right, so let's go ahead and start with some local variables. So we're going to continue working on our current run view controller, and I'm going to create some first of all a mark local variables. So as you can see, when I type cl location, it's not coming up because we haven't imported from core location. So let's go ahead and import from core location, and there we go. So we're gonna keep it forced unwrapped, and we are going to populate this before using it, so it's not gonna be crash. But yeah, this gives us an opportunity to basically keep the nullable instance. So we're gonna keep the run distance. This is just gonna be another local variable, and there's gonna be time elapsed. and a variable to keep the pace. Okay, we also gonna initialize our location manager, and a timer. All right, so now for the view life cycles, the first thing we're going to do is, once again, we're going to set up our views, a function for that, and set up constraints. Right, so now we're gonna be able to add our views and basically our constraints. Okay, so that's for setting up our view. But on view did load, or view did appear actually, what we want to do is, first thing we want to call view did appear for the superclass, and we're also gonna call the location manager and get the manager and assign ourselves as the delegate, and we're gonna create a function called start running. Okay, all right, let's go ahead and create our extension. So current run view controller extension, and we want to extend CL location manager delegate because we want to keep track of, like, you know, where user is running, so we can actually track their location. Okay, so that's what we're gonna do with the delegate. On the view did we will disappear, we want to stop the run, so view will disappear. We're gonna call stop run, and we are also gonna call super dot view will disappear animated. Okay, so it's gonna be another function. There we go. Okay, so now for the start running function, what we want to do is we want to call our location manager and we want to call start updating location, not the heading but the location. So this is going to start sending events whenever user would start running, and we also want to basically update our labels for pace and, like, you know, time and stuff like that. So we're gonna call a function called start timer, and this timer function is gonna keep basically the timer, and gonna be responsible for updating those labels, right? And when you stop running, we want to call location manager dot stop updating location. Okay, and we want to call stop timer here because we do want to reset our stop the timer and reset it. So we're gonna call or create a function stop timer, like so. All right, so now when we have, like, you know, our start timer and stop timer, let's go ahead and put some code into that too. So our time label text is going to host the time that has been elapsed. So time elapsed has int value. Now we do want to format that into a time string. Okay, so the way we can do that is we can create a new file, and we're going to create an extension on the int. Okay, And so we're going to call this int plus extensions. Okay, and this basically what it's going to do is it's going to receive the integer time elapsed, and which is going to be in seconds, and we're going to convert that into a time string. Okay, so we're going to simply say extension for int. Okay, and we're going to call format. The function is going to call format time string, and this is going to return a string. Okay, so we're going to first compute hours in the time, so we're going to say self divided by 3600, which is 60 times 60, so 3600 to get the hours, number of hours so far in time lapsed. Then we're going to have minutes. So minutes we can get by self dividing or modding that with 3600, whatever the remainder is, divide by 60 will get us the minutes. Okay, and then you have seconds, which is once again self mod 3600, and we're gonna mod this by 60, and this is gonna give us remaining time, which is gonna be seconds. So if seconds is less than 0, so in that case we're gonna simply return 0 0. Otherwise we're gonna say if hours is equal 0, so in that case we don't want to show the hours label, so we're gonna simply return string format, and this is how you format the string. So you can pass basically the format string, which is going to be %0 to d. Okay, and colon, that's what we want to basically separate our time with, and %0 to d, another one. And this is going to take get the minutes and seconds. So essentially what this is going to print is if it's 12 minutes 25 seconds, this is going to be printed as this format. Okay, now in case of else, we're gonna return a string with format, and this time we're gonna have 3 of these. So %0 to %0 to d colon %0 to d colon %0 to d, and this is going to be, first one is going to be for hour, second is going to be for minutes, and third one is going to be for seconds. All right, now going back into our file, we're going to simply call this time format time string, and this is going to format our time elapsed into the time format. Okay, so that is your start timer. First thing you're gonna do that, and then so this is gonna basically if the time has if the time elapsed is just initialized with 0, then the format is gonna be 0 0 0 0. Okay, and then we're gonna set our timer or reinitialize our timer with timer dot schedule timer with time interval. Okay, and time interval is gonna be every second. We're gonna target set the target for ourselves. There's gonna be a selector which we're gonna call this update timer. Okay, user info is gonna be nil, and we're gonna keep repeating this timer every second. Okay, now about this function, we're gonna just create that at obj private func, like that. Okay, so this is gonna be your start timer, right, which is gonna basically set the label with 0 zeros, initialize the timer. For the stop timer, what we want to do is timer dot invalidate first. Okay, and set the time elapsed to be 0. All right, and this function, the timer schedule timer, is gonna basically take the responsibility to start, like, running the timer. So then we wanna update our time lapsed every second with 1. So we're gonna keep adding 1 into that, and we're gonna update the time label.text is equal to time elapsed dot format time string. Okay. All right. We need one more function, and this function is gonna basically compute our pace. Okay, so let's see. All right, so compute pace, what this is gonna do essentially is it's gonna take the time in seconds and miles that we have tracked so far, which we're gonna do inside the extension, and it's gonna basically compute the pace at which user is running. Okay, so we're gonna create this function and we're gonna use this very soon. So compute pace for time in seconds, which is going to be int, and miles, which is going to be in doubles, and this is going to return us a string, and we're going to simply say pace is equal to int value. We're going to get the double from seconds, and we're going to divide that by miles. Okay, and that's how we're gonna get our pace, and we're gonna return pace dot format time string. Okay, so those are all of our helper functions. Now let's go ahead and set up our view. So we're gonna first add sub view for top label. We're gonna add sub view for page stack view, and add sub view for capsule view. Now capsule view dot add sub view a stop slider knob. Capsule view dot add sub view slider stop. Okay. All right. Now for the swipe gesture, now this slider needs a swipe gesture basically, and we're gonna use the UI pen gesture recognizer, and we're gonna attach that to the slider knob. Once again, going back to the app, this guy right here is the pen gesture that we are applying in X direction, and that's what we need. Basically, we need this to be applied. So what we're gonna do is we're gonna simply create it inside the setup view. So let swipe gesture is equal to UI pen gesture recognizer. Target is going to be self, and the selector is going to dismiss the view controller. So we're gonna say dismiss and we're gonna have a sender here. Okay, and gonna create that function. Dismiss end. It's gonna have a sender UI pen gesture recognizer. Okay, and then we're gonna attach this swipe gesture to our stop slider knob. So add gesture recognizer, swipe gesture, like so. All right, so that is our view that is set up. Now for the constraints, what we're gonna do is we're gonna set up our top label first. So we're gonna set it to leading trailing top, and height. So leading, trailing, top anchor is going to be constrained to view dot safe area layout guide dot top anchor, and for the height we're gonna say equal to constant, and we're gonna put that constant of 50 as a height. Okay, now next thing we wanna set is page stack view. So page stack view, once again this is the stack view that contains all of our labels, so we're gonna simply say ns layout constraints dot activate, and we're gonna set page stack view dot leading anchor dot constraint equal to view dot leading anchor. Trailing anchor is going to be constrained to view dot trailing anchor. And for the top anchor, we're going to constrain this to top label dot bottom anchor with the constant 8. Okay, now for the other constraint, we're gonna define that inside our capsule view, because we want to create a relationship between our page stack view and basically a constrained relationship between our page stack view and capsule view. So let's use the capsule view layout constraint dot activate, and we're gonna say capsule view dot width anchor is gonna be constrained to $300. Okay, and height is gonna be constrained to 70, and then bottom anchor is gonna be constrained to view dot safe area layout guide dot bottom anchor. Okay, and capsule views top anchor is going to be constrained to page stack view dot bottom anchor with constant 8. Okay, so this is basically going to create that that constrained relationship between the capsule view and the page view. And one last, we want to have our capsule view to center in X direction, so we're going to constrain that equal to view dot center X anchor. Okay, now these are all of our main views. Now how about our stop button inside the capsule view and slider stop knob? Okay, so let's go ahead and create constraints for those. So stop button slider stop button or knob. Basically this is just a location because we are gonna create basically we gonna, whenever the slider pen gesture happens, we wanna check if the sliding knob is essentially so whenever the pen gesture happens, we're gonna check if the sliding knob's center has collided with the center of the stop button, right? And that's how we're gonna detect and dismiss. Okay, so so that's what we're gonna actually sort of like, you know, plan for this. So this is not essentially not exactly a button, so that's why I didn't I kept calling button, but it's not. Okay, so it's a stop slider knob. Sorry, stop slider knob is the slider that you're sliding, is this guy right here. Okay, the one that you're sliding. So we're gonna have that. All right, so stop slider knob leading anchor is going to be constrained to capsule view dot leading anchor with constant 8, and stop slider knob dot center y is going to be constrained to capsule view dot center y. Okay, and then its width anchor is going to be constrained to 50, and height constraint is going to be constrained to 50 as well. Okay, so we're gonna make it a circle. All right, so that is the slider knob, this guy. Okay, now we need this button right here. Okay, so this is like slider stop circle or image. Okay, and as layout constraint dot activate, and we're gonna call this slider stop dot trailing anchor dot constraint equal to capsule view dot trailing anchor. Okay, slider stop dot center y constraint equal to capsule view dot center y, and slider stop dot width anchor dot constraint is equal to constant, and this is going to be 70. I'm gonna copy this and paste it, and gonna change this to height. And if you notice, this one, this stop button is slightly bigger than the slider button itself. That's why we are actually creating it as 70. Okay, now there are just a couple more things left, so let's go ahead and finish those. So first of all, the dismiss and. Okay, so this guy is when we are actually gonna recognize that gesture that the slider has passed or collided with the center of the stop button. So let's first create an adjust variable. So it's gonna be of CG float, and we're gonna have 35 as a computed value, which is half of 70. Okay, and we're gonna use that inside our computation. Then we're gonna have translation, which is gonna be sender dot translation in view. So how much it has translated, like, you know, since the pen gesture has started, like, you know, whatever the value that your pen gesture is sending for the translation itself. Now we're gonna detect the state for the sender. If the pen or swipe gesture has began, or sender dot state is in change. Okay, so if the slider has begun sliding or it has changed, that means it's continuously sliding, then go in this if block. Otherwise, if sender dot state is ended and stop slider knob dot center dot x is less than slider stop dot center dot x. So basically you have stopped somewhere in the middle, and your two centers are not colliding. Essentially what we want to do is we want to bring this button back to the initial position. So what we're going to do is we're going to simply say UI view dot animate with duration, and duration is going to be 0.5, and the animation itself is going to be self dot stop slider knob dot center dot x is equal to self dot capsule view dot bounce dot min x plus adjust. Okay, so it's going to bring it back to the initial value with 35 points, like, you know, shifted 35 points for the center. Okay, So that is when user leaves the knob in the middle. But what if they have begin and, like, it's going, it's sliding, then we want to do few checks in that case as well. All right, so the way we're gonna do that is first we're gonna put a like if statement. If the stop slider knob dot center dot x is greater than slider stop dot center dot x, okay, or we can actually say it's greater than equal to, okay. If that is the case, that means this is the state where collision has happened. So we're gonna say stop slider dot center dot x is equal to slider stop dot center dot x. So we're gonna just basically align their centers so it's right behind, and we're gonna call stop running or stop run. We also want to dismiss our view in this case, and we're gonna dismiss it with animation as true. Okay, now that is the first case. Now what if the center, the stop slider knob dot center dot x is less than the capsule view dot bounds dot min x plus adjust? Okay, if that means if the slider has gone, basically slider is trying to slide beyond these limits for the capsule, then we want to actually bring our slider back. So we're gonna say stop slider knob dot center dot x is equal to capsule view dot bounds dot min x plus adjust, because we and I just realized I've actually misspelled this, so rename. There you go. Okay, so we're gonna adjust that, right? Or we're gonna actually bring it back. And last case, if none of this is basically none of the conditions are true, then we want to take our stop slider knob dot center dot x and add translation dot x to that, so we can actually reflect that inside our knobs translation. Okay, all right, now let's do the last thing, and this one is basically getting the updated location. So did update location is a function that is called whenever the new location update is available, and we want to say if the start location is nil, that means our run has just started, right? Then we want to say start location is equal to location dot first. All right, so we're gonna initialize that. Else if we're gonna first get the location from locations dot last, and locations is coming from here, basically the locations that have been tracked by core location, and they are actually giving it to us. We're gonna say run distance is equal to, or run distance plus equal end location dot distance from the location that we have extracted from the last location. Okay, and then we're gonna say self dot distance label dot text is equal to self dot run distance. Now the distance actually comes in meters, but we need to convert it into miles, and then we need to convert it into a string with 2 places of decimal. All right, so best way to do that is create another helper, and we're gonna call this one double plus extensions. Okay, and this is basically going to include the extension on double, and there are going to be 2 functions. First function is going to be meter to miles, which is going to return a double value, All right, and there's going to be a function toString places, and we're gonna see like how many decimal places we want, and we're gonna return the string. Now the way we're gonna return, we're gonna actually create a string with format, and we're gonna say percent dot and places that's been passed into us for self, and this is going to be f here, okay, for decimal values. And here the meters to mile is simply you're gonna say meters is equal to, we're gonna use the measurement, and we're gonna supply the value self, and basically tell the unit length is going to be meters. So currently so we can actually take that double value, convert it into a measurement of type meters, because we know that value is coming from in meters, and we're going to return meters dot converted to miles. Okay, and we're going to take out this value and return that, and that value is going to be double. So that's how we don't have to worry about like the computation. Let the measurement framework figure out how to compute the miles for us. Now going back into our update location, the run distance is gonna have meters to miles, and we're gonna call that, and toString is gonna be, we need this value up to 2 places. Okay, now we want to say if the time elapsed is greater than 0, right, and the run distance is greater than 0, if these two values are 0, then we also want to update the base label to the computed value. Compute, remember this compute paste function that we created, we can actually call that, we're going to pass our time elapsed into that, run distance dot meter to mile as well. Okay, and one thing that we want to make sure that we do is we also want to populate our end location with locations dot last. All right, so that is all there is basically for our current run. Now when we go like into our home view, we want to make sure like that we are calling this current run somewhere. Okay, so let's go to our home view, and at this point we are not calling, so whenever we click on the start button, start running, we simply say like print. So if you want to change that, we're going to create let current vc current run vc is equal to current run view controller, and we want to say current run view controller dot modal presentation style to be full screen, so we don't want it to be dismissible modal, and like then we're gonna just present current vc animated true, no completion. All right, let's go ahead and launch this, and what we should see is basically our user is still running, and we want to click on this run button, and there we have our labels, and as you can see our labels are updating. And let's check out this guys. So as you can see there is as soon as I touch there is like automatic slider that's going in. Okay, so let's take a look. What is the issue on the sliding? All right, so for the slider we have the translation going in the view. If the state has begun or changed, we want to say so let's see if that actually helps. No, it did not. Okay, so slider knob dot center is equal to slider dot stop, but there's a pan gesture, so we want to say if the slider stop dot center dot x min_x. All right. So it looks like this line. Oh, okay. So there's one thing that we actually forgot is we forgot the translation. So sender dot set translation. Basically, this sets the translation value to the coordinate system, right? So this is where we need to set it to 0, so it can actually continue to update. Okay, so let me go ahead and update that. And if you notice now, because these set translation is now local, now it's not actually sort of just sliding away until we actually reach to the end, and when the actual centers collide. And as you can see, our pace is increasing, our distance is also increasing, so our labels are updating just fine. All right, so this is our this was our current run, and next we can actually work on our logs page, okay, which is gonna just have a table view for this, and then we're gonna introduce realm, and once we introduce the realm, then we're going to start using realm database. Whenever we are dismissing the run, we are actually going to store it in realm, and this logs page is going to pull that information from the realm itself. But in order to create the view, we're just going to create that in next video and get the view ready and set up, and then we're going to introduce realm part. All right, so let's go ahead and create, or basically populate, our history view controller. So what we're going to do here is first of all, we're going to create a private static let a reuse ID for our table views. Okay, and then we're going to create our UI elements. So let me actually create a snippet for this, and that'll actually show you how I have created this snippet for Mark as well. So I'm just simply gonna select the text I want to convert it into a snippet, and I'm gonna right click, basically create snippet, and I'm gonna call this one PLV, just for the initializer private lazy var. Okay, and I'm gonna save that. All right, now if I say PLV, let's see, okay, so there's our code snippet. Now we can delete this one, and for this one there's no completion, so let's edit this, and we're going to call this PLV private lazy var. Okay, call it done, and now let's try it. PLV, there we go, private lazy var. All right, so you're gonna have top label first, UI label, we're gonna set all the properties for our top label. Okay, and then we're gonna have our table view. So PLVP, there you go, private lazy var table view, UI table view. We're going to set the selection to false for now. We're going to set ourselves for delegate and data source. We're also going to register a cell class, and let's set it to UI table view cell dot self for now with the self dot reuse ID. Okay, and we're gonna come back and change that when we create our table view cell. Background color, we're gonna set it to clear, and for the separator inset, we're gonna say UI edge insets, and we're gonna say it's gonna be 0 0 0 0. So separator is not indented, and for the separator color, we're gonna say it's gonna be the white color. Okay, all right. View lifecycle, setup views, setup constraints. Okay, and all right, we're gonna basically add our label. So add subview top label, and we dot add subview our table view. Okay, we're gonna add those two, and we're gonna set the constraint for top label. We're gonna set the height equal to constant and 50. Okay, next is basically our table view constraints. So table view dot leading anchor dot constraints equal to view dot leading anchor. Okay, all right, so now we have all the constraints set up. We want to create our extensions, and we're gonna have basically extension. So extension to our history view controller, which is gonna be conforming to UI table view delegate and UI table view data source. Okay, and we're gonna have number of rows in section, and we're gonna return maybe 10 here. Okay, and cell for row at index path, return UI table view cell for now. Right, and we also wanna estimated height for row at, and we want to return UI table view dot automatic dimension. All right. Okay. So these are all the extensions, and now if you build, there should not be any error, but what we want is basically to have our cell created. The cell is basically right now we are using UI table view cell, but that's not gonna cut for us because we need our own custom cell. So we're gonna create a new view here, and this we're going to select a Swift file. I'm going to name this history table view cell. Okay, and import from UIKit. All right, we're going to create final class history table view cell, UI table view cell. All right, then we're going to have some properties that are going to basically set our internal UI components. So let me first create the UI components. Right, so total miles, label. This is going to be a UI label. Text is going to be 0.0. Text color is going to be white, and font is going to be UI font dot bold for system size 24. Okay, then we're going to have another one, total time label. All right, text needs to be in a string. Once again, v dot text color is going to be the white color for this label, and font is gonna be v dot font dot width size 18. Right, so that's gonna be our total time label. Then we're gonna have an entry date, so basically entry date, date on which the run was recorded. We're gonna have that. Okay, so all right, and I'm gonna actually copy these things because they are going to be exactly same. All right, okay. Now on to our properties. The setter properties, the properties that are gonna basically be set to basically populate these labels. Okay, so external props. Okay, and we're gonna create a variable total miles. Okay, it's gonna be of type double. Default value is gonna be 0.0, and we're gonna put did set observer into that. Whenever this is set, you're gonna say total miles label dot text is equal to string format 0.1 f percent 0.1 f, and then total miles. All right, and we're also gonna call layout if needed, because our text is going to change. Okay, total time is gonna be a string, which is gonna have default value 0 to, I'm just gonna put something in there. I mean, we're gonna have like actual values like very soon, but these are just placeholders. So we're gonna put did set total time label dot text is equal to total time layout if needed. Okay, and the entry date is gonna be a string. There we go. Okay, so these are going to be all the external properties that we can set. Okay, now we need a like an initializer. All right, so we're gonna say first we're gonna call super.initializer, pass the style and the reuse identifier, and we're gonna call setup views here. Okay, and the setup constraints is going to be called in layout subviews, layout subviews override function. Right, so we are going to create this required initializer, and then we're going to create our private function for setup views, and this is going to first of all set the background color to be UI color dot black dot with alpha component 0.1. Okay, so slightly tinted, and then we're gonna say content view dot add subview total miles label, content view dot add subviews total time label, and content view dot add subviews entry date label. Okay, now we're gonna create our function for setup constraints. So private func setup constraints. Okay, and this guy is going to first lay out the total miles label. So we're going to have only two constraints in this. Leading anchor is going to be to content view dot leading anchor with constant of 16, and total miles label dot top anchor dot constraint is equal to content view dot top anchor constant is going to be 16. Okay, then next comes our total time label. All right, so this one is going to be total time label dot leading, so leading anchor dot constraint is equal to content view dot leading anchor constant is going to be 16, and total time label dot dot top anchor is going to be constrained to total miles label dot bottom. Okay, and you can have constant of 8. Okay, so there's a gap between those two, and then total time label dot bottom anchor is going to be constrained to content view dot bottom anchor with constant of -16. Okay, and then we can have our entry date label. Once again, in this layout constraint, activate entry date label dot trailing. So basically this is going to be located at the trailing end, so trailing anchor dot constraint equal to content view dot trailing anchor. Constant is going to be -16, and entry date label dot center y anchor dot constraint equal to total miles label dot center y anchor. Okay, now this guy is not going to be called from initializer, because remember, we have our layout being driven from auto layout. So what we're going to do is we're going to call layout subviews. We're going to call super.layout subviews. Okay, and then that's where we're going to call our setup constraints to make sure all the constraints are set up properly. Okay, it doesn't hurt to call it here as well. Okay, all right, so that's our history table view cell. Now let's go back to our history view controller, and instead of this, we're gonna call history table cell, like so. Okay, so history table view cell dot self. Now when we were setting the cell at the bottom right here, we are actually simply returning UI table view cell. So now we can actually put a guard statement, guard let cell is equal to table view dot dq reusable identifier self dot reuse id. Okay, that's what we have registered, and we're gonna say try to cast this as history table view cell. Okay, if you can, that's great. Otherwise, return UI table view cell. Okay, now we actually are getting the total miles. So we're gonna simply take our index path dot row and convert that into double. That will give us, like, just total miles, just some placeholder data that we can actually put, so we can see our labels. Entry date is okay, and return cell. Okay, so with that, let's go ahead and launch this, and what we should see is basically a table view with all the details, like that we have. So 0, 1, 2, 3, these are our indexes, these are our times, and these are our dates. Okay, all right, so that brings us to the end of this whole run tracking and run logging UI screen. Now next part is going to be about Realm and how to store this data into Realm database, and then retrieve that to display it here. Okay, so we're going to be making some modifications and into the project, and we're going to be also introducing new dependencies using CocoaPod. All right, hello and welcome back, and in this video we're going to be from now onward we're going to be basically working with Realm integration, and we're going to also refine our app a little bit more, basically include some minor polishing effects, basically. Okay, so let me show you, like, what the final product is gonna look like after the Realm integration and a couple of changes that we are going to do. So your home screen is gonna stay, like, the way it is, but as soon as you click on run, this screen we already have built, but, like, there is a little bit of change that I'm gonna basically try to do here. And one of the changes, if you notice, as soon as we launched this screen, we had an animation indicating to the user that this is a slidable control. So we're gonna add that animation, and we're gonna add this text, this shimmer text at the top, like at the center. And if you notice, there is a shimmer effect, just like iPhone had, like, slide to unlock, sort of like the same effect. So we're going to be creating that, and I've changed the icon right here to have the an arrow, to have basically an arrow pointing, like, in horizontal direction, indicating that this is a slider, sliding only in this direction. If I try to, like, slide the other way, it's not gonna work. Yeah, so that is like, one change. So let me show you once again the animation. So there you go. So this is the animation that we're gonna build, essentially letting our user know that this is a sliding control. Second change we're gonna make is gonna be on this log screen. So right now, if you notice in our last video, when we finished our app, we had like, indexes, but these are actual reported miles, runs, and, like, basically some of the other information that there is. So so what we're gonna do is we're gonna store all this information inside a Realm database. Okay, that's going to be one thing. And then we also, if you remember, like, we made it unselectable, the table itself unselectable. But what we're going to do in this case is we're going to make it selectable and launch a modal to indicate or to show where the run was. Okay, so for example, let me find the longest run. Maybe this is a 1 mile one. So I'm gonna click on this one, and notice how we actually have this run. It started around here, and the user went around, like, and they went in this direction and then came back, and the run stopped somewhere around here. Okay, right there. So you're gonna basically drop these pins, like, customize them, and basically look at how those pins are gonna basically draw this line, the run location on the map. So all that we're gonna do in this, and we are also gonna create this view, this run log view, run log detail viewer. Let's see, what did I call previous run detail view controller? Yeah, and we're gonna have, like, this custom slider to slide it back. Okay, so these are going to be some of the changes from the UI side, but again, there are like few more changes on the code side. For example, we're going to be adding a dependency for Realm, and there's a library that I'm going to be using for that shimmer effect. It's called Shimmer Swift. So we're going to be adding a pod for that. So let's go ahead and add our configure our project to get it ready for CocoaPod, and then we're gonna use we're gonna install all the dependencies and basically get going on that. Okay, so first thing we're gonna do is we're gonna open our projects folder, and I'm gonna right click and basically open a new terminal at the folder. Okay, and then I'm just gonna do cd dot and ls. Okay, so this is where we want to be, basically at the root directory where you have your XC project set up, or like, the file visible. So just do ls and you'll actually find out. So let me see if we can see this. Okay, all right, so all right, so once again, let me clear. We're going to do ls to make sure we are at the root of the directory where we have our project listed and our Xcode project file listed. Okay, and here we're going to do pod init. Okay, before doing pod init, if you're not familiar with the with the Cocoa Pod, go ahead and search for Cocoa Pod inside Google and go through the installation process. But I'm pretty sure like you guys are are aware of that, so I'm not gonna go into that. By the way, Pod, I already have Pod installed, that's why I was able to just do that. Now once you have Pod install configured, you will be able to do the same thing. Just pod in it and it'll create a pod file in your folder. Okay, now we're gonna actually modify this pod file, and what we're gonna do is we're gonna simply say vi pod file. Okay, and I'm gonna go ahead and add two of the pods. Okay, so first one is going to be pod for Realm Swift. This is basically for to add support for Realm database. Okay, and pod Shimmer Swift. Go ahead and look these pods up to get to learn a bit more about them. So yeah, these are the pod names, and you should be able to, if you search pod Realm Swift or pod Shimmer Swift, you should be able to find the documentation for those. All right, with those two pods added, I'm gonna escape and press Shift Z twice to save the file, and I'm gonna do pod install. Okay, what this is going to do is it's going to download all the dependencies and install those dependencies. Now this project is not going to be the one that we're going to be using, as it states here that two other dependencies have installed, and close all the current session and use the XC workspace file. Okay, so what I'm going to do is I'm going to say open dot to show you what the current new structure is. So if you notice, there is a pods folder that is created where we have all the pod related dependencies. There's a podlock file indicating what versions of pods you have installed. You have this Xcode project file which was created, which we were working on, but the new file that workspace is created, which is gonna have reference to these pods. So let's go ahead and open that one. Okay, and I'm going to close this folder, and there we have it. So this is our XC project. Okay, and if you notice, our pods are there. This is our pod file, and we already have this pod file added, and both of our pods are listed there. Okay. Now what we're gonna do is before we actually before we do anything, let's go ahead and give it a run to make sure that there is no issue or like build error or anything like that that is happening, and then we're gonna start working towards our project. Okay, so I'm gonna give it a minute, like a few seconds, not a minute, and then we'll go from there. Okay, so I'm gonna pause the video and come back when the build is finished. All right, so it took about 20 seconds to build. First build is definitely gonna take a little bit time because you are adding a new dependency and all the binaries have to be compiled. But there we go, we have our project created, and it's actually launched inside iPod Touch, which is fine. I'm gonna stop that, and I'm gonna actually change this to launch on iPhone 12 Pro Max. Okay, I'm gonna close this one. All right, so let me go ahead and launch it here. Okay, there we go. So everything seems to be working fine. Yeah, okay, awesome. So we have our project ready to go. Now in the next video, what we're going to do is once we have our once we have our realm setup ready to go, we're gonna first work on our models, and models are basically where we're gonna create our run model, and it's gonna represent our realm database, and we're gonna write some realm database related properties there, like to add, run, and to get all the runs and stuff like that, some helper functions, and that is going to help us like contain all the database related stuff inside one file. And similarly, we're going to create another one for a location, to save the location where user is running. That way, we're gonna have both of those models ready for us to use inside the realm database. Okay. All right, so let's go ahead and work on our models now. So I'm gonna create a new folder, and this one is going to be called models. Okay, and first one we're gonna create is going to be called run, which is gonna store basically have the schema for the run object, and it's also gonna have the common operations or the functions that we're gonna do on run object. Okay, so first thing, import realm Swift. All right, now in case of realm, your model has to basically inherit from object, like here, and this object is a class created inside realm. Okay, so it has to inherit from object, and that actually represent that this is actually your table. You can think of this as your table. Now your table is going to have some columns in it, and those columns are going to be represented by properties. So let's go ahead and create some of those. So we're gonna say obc, and this is pretty standard realm property creation, so there's nothing really crazy about this one, and I'm going to talk about it in a minute. Okay, so for realm objects, they have to be Objective-C, they have to be decorated with @obc, they have to be dynamic, and then public private set is basically just your regular property creation. Okay, and here we are creating an ID. All right, what this is going to help us is basically it's going to help us create that dynamic model that realm creates. So these few keywords are going to be same, so I'm just going to copy them and paste them and create some more properties. So one I need for pace, I'm going to initialize that with 0. Another one for distance, I'm going to initialize it with 0.0. Essentially this is gonna represent double type, and realm can support various different native data structures, for example int, double, string, etc. So you're gonna actually use all of those, whichever we need to. You're gonna have duration, which is gonna be 0, and we're gonna have a date, which is gonna be of date type. Okay, and date type is supported in realm natively. All right, then we are also gonna have a public private set. Essentially what this means is this property is going to be settable within the class but not from outside. Okay, and this is going to be a public property to be accessible read-only from outside. Okay, so public private set var, and we're going to call this locations. The variable name is just going to be a list of location. Now this list is realm object, realm type. Okay, so list is a container type in realm, and it is used to define to-many relationship. Okay, so that's what list is, and location is something that is not created yet. That's why it's actually complaining. So let me go ahead and create a new file, and I'm going to call this location. And this basically class is going to represent a location table inside our Realm database. So import Realm Swift final class location. It's going to inherit from object. Once again, I'm going to paste our keyword for creating variables like add object dynamic public private set var, and we're gonna store latitude. Okay, we're gonna store them as double because in CL I forgot the name. Anyways, the coordinates that there are, like, you know, in the code location, they are like, you know, natively created as double. So we can actually create them. We can store them as double, and then we're gonna retrieve them and cast them back into CL location coordinate 2D. There we go. That's the name, CL location coordinate 2D. I guess this is it. So anyways, longitude is going to be 0.0 as well. And then we're going to create a convenience init, and this convenience init is going to take a latitude and longitude, and we're gonna initialize self because this is a convenience init, and we're gonna say self dot longitude is long, and self dot latitude is lat, like so. Okay, so this is our location class. That's about it. This is this table is gonna have two fields or two columns, and then we're gonna have, like, you know, this relationship, one-to-many relationship between our run and the locations, and we're gonna have our locations created here, list of locations. Now we wanna override the primary key to tell Realm what our primary key is gonna be. So you can simply type primary key, and it's gonna basically fill the rest for you. It's an override, and you're gonna return ID here. Okay, this ID right here is what we are calling as primary key. So we're gonna say, like, you know, this is gonna be the primary key for us, and then for the another override that we're gonna create is gonna be for the index property. What are the properties that we are indexing? So we're gonna say return an array. So this expects an array of string and column names. So we're gonna have pace, date, and duration. These three properties are going to be indexed. Okay, and if you are unsure, just date and pace are good. Okay, yeah, so these are going to be the index properties, and then we're going to create our convenience init. So convenience init, and this is going to take pace as int, distance as double, duration as int, and locations as list of location. Okay, and we're gonna first initialize self, then self dot date is equal to date, self dot pace is equal to pace, distance, duration, location. Okay, so let's take a look. We've got everything. Date is equal to date. Oh yeah, there's no date. We're gonna mark it as current date. There we go. Okay, so date, pace, distance, duration, locations. Perfect. Okay, now when it comes to the operations, like adding record to this table, is something that we can contain in this class itself. That way, like, all the operations related to run are gonna stay within this class, and that's what we're gonna do. So we're gonna create a static function. Okay, we're gonna call this add run to realm. All right, it's gonna expect us to pass space, distance, duration, and locations. All right, and what we're going to do with this information is we're going to store that. Okay, so before we store, we need to actually create a separate queue for realm. That way, like, we can always launch realm related stuff inside that queue. So I'm gonna go into the helper and create a new file, and this file is gonna be called constants. Okay, and this is gonna be a simple class called constants, and it's gonna have a static let realm queue dispatch queue dot with label. Gonna label it realm queue. Okay, now let's go back. All right, so now we're going to use this realm queue to store our data. So we're going to always call our operations on this queue, like, whenever we are writing. So we're going to simply say constants dot realm queue dot sync. Okay, so we're going to synchronously do that, and do let realm try realm. So we're gonna get the reference to realm, and we're gonna say try realm dot write. Okay, and we're gonna write a block. Okay, and inside this block we're gonna simply write realm dot add run. Okay, and we're gonna give our pace, distance, duration, and locations. All right, we also want to make sure that we call commit right. Okay, and that is going to get our records saved inside the realm database. Now we're gonna create a catch, and let me create a debug print, and debug print is gonna print for when we are in debugging mode. Error adding run to realm. Okay, so this is basically going to be our add to realm function, and that's it. Like, this is all it takes to write a record inside realm database. So realm is absolutely amazing. Okay, now we need one more function to get all the runs, and we're gonna simply create another static function for that. Get all runs results run. Okay, it's going to be optional, and we're gonna once again do this inside do catch block or do try catch block. If we could not get any run, if there's any error, we're gonna return nil. Otherwise, we're gonna create realm first. So realm. Okay, we're gonna create a collection for run. So run collection realm dot objects of type run dot self. Okay, so get the objects, and run collection is equal to run collection dot sorted. So we're gonna now sort this. So sorted by key path ascending. So this is what we want, and we want to sort these records by date. So we're gonna specify that, and we want to set ascending to false. Okay, and now we're gonna return this run collection. Okay, So this is basically a return the collection of run that we have actually fetched from our realm database. All right, so yeah, so this is it for all the realm related stuff that we need to do. Now what we're gonna do is we're gonna start using these classes and start storing our run record inside the realm database. Hello and welcome back, and in this video we are going to be making some adjustments to our views that we have created earlier in order to accommodate for the new changes. Okay, we're gonna start with this history table view cell. Okay, so history table view cell is what we are showing the history. So let me open. This is the logs that we are showing, right? Now the change or one new function that I want to include is basically configuration options. So if you remember, if you go back to your history view controller, you're going to notice that we are setting 3 different values for the cell. So instead of this, we can clean this up a little bit better by passing an object into the cell and then configure cell over there. So we can pass run object and then configure each individual cell. So I'm going to create a configure function which is going to expect run. Okay, and run is supplied to us, the run object, and what we're going to do is we're going to say total miles is equal to run dot distance dot meters to miles. Okay, so we're gonna store run there. Total time, we're gonna store run dot duration dot format time string, and entry date, we want to format the date into a string. All right, so we can actually get the string and format it. So there are 2 ways. You can either use a date formatter, or you can actually do it by using calendar. So today I'm going to show you how to use calendar. You must have seen the date formatter, but I just want to show you another variation. So we are going to create a new file here, and we're gonna name this one date plus extensions. All right, and in this we're gonna simply create an extension for date, and in this we're gonna create a function get date string. This is going to return a string, and what we're going to do is we're going to first get the reference to current calendar. So calendar dot current. Okay, and we're going to get the year from that. So calendar object dot component, we're going to get the year component from self. Now since this is an instance function and we are calling on the date, self is going to represent a date, and we're going to get the year part of the date. And now we're gonna once again reach out to calendar and say give us the month for self as well, and day the same way. Okay, and we're gonna return a string with month slash day slash year. Okay, so this is how we can actually convert that date into a string. Just another way to format string date into a string. Okay, so we're going to say get date string. All right, so this is basically what this is going to do for us is it's going to give us an ability to just call the configure, and instead of writing 3 lines to basically do this, we are simply going to get the run and kind of display that. All right, before we do that, we're gonna just comment call configure cell here. Okay. All right. So before we do that, we want to make sure our history view controller is ready to get the run, the collection of run. So when we get it, we actually sort of populate that inside our table view. So what we're going to do is in our table view cell number of rows in section, we're gonna reach out to the run class, and we're gonna say get all runs. Remember, this function was a static function which is gonna query the realm and get us the results. So we're gonna say dot count. If the count is there, return that, otherwise return 0. Okay. Now in case of this cell for row at index, we are first of all getting the reusable, we are dequeuing the reusable cell, making sure it can be casted into history table view cell. The other thing that we're going to do at the same time is we're going to say let run is equal to run dot get all runs. Okay. And we're gonna just get the index path dot row, else we're gonna say return an empty cell. Okay, so this is gonna give us one run instance, like, you know, for the current index, and we're gonna say well, cell dot configure run. So we're gonna supply our run that we have extracted right here. All right, so this is basically going to get us the run. All right, now whenever user has selected that run, we want to show something. Now right now the selection is disabled, so we're gonna go here, allow selection, we're gonna remove that. Okay, and what we're gonna do here is we're gonna say at the end, inside the extension, we're gonna say did select row at index path. Okay, and we're gonna guard once again, guard let run is equal to run dot get all runs dot index path dot row. Okay, if it's there, otherwise return from here. Let vc is equal to the vc, the view controller that we're going to be launching when we actually have the run. Instead, what we can do is right now we can simply print maybe run dot distance dot meter 2 miles dot string places 2. Okay, we're just gonna print that. All right, so right now at this point we are not saving our stuff into the database. I'm gonna just put a comment here, launch run detail view controller here. Okay, all right, so next thing what we need to do is we need to first of all go into our current run, and inside our current run, whenever we are stopping the run, we need to actually save that information, the run information, inside the realm database. Okay, so that's going to be the next what we're going to do, and after that we are going to go back and create our previous run detail view controller and set that up. Okay, all right, so let's go ahead and set up our current run view controller. Okay, so what we're going to do first, let's start setting things up, like, you know, for example, we need to set up the text that we want to show, the shimmer text. Okay, and so let me pull up the app, the final version. Okay, so we're gonna set up this change this button, set up this shimmer effect and the label, And I will also rename this view that we called capsule view to slider view. So let me first do that. Rename this to slider view, just so we can identify it easily. And at the top, I'm gonna import from Realm and Realm Swift and import Shimmer Swift. Okay, those two things we're gonna need. And then what we're gonna do is we're gonna first create our slider text. Okay, so right underneath slider stop, we're gonna create a private lazy var slider text, which is gonna be a UI label, and I'm gonna say UI label slide text is equal to slide to stop. Text color, let's give it white. And size, we're gonna give it 24. Okay, let's see, 24 is subtitle font size, so we can actually change that to self.subtitle font size. Okay, then we're gonna create our shimmer view. So we're gonna say private lazy var slider shimmer. Okay, shimmer view or shimmering view is equal to shimmering view. And shimmering speed, we're gonna set it to 1, and shimmer pause duration is gonna be 3. Okay, there are various other properties that you can set for this control. I'm just gonna set these two. Okay, the other thing I want to do is instead of this guy right here, we're gonna change it to arrow dot left dot and dot right dot circle. Okay, let's go ahead and take a look. I know we haven't constrained the slider text yet, but I want to see, like, you know, our arrow being changed, so that's good. And it still works good, so we can stop that now. Okay, so now stop.circle.fill. Okay, perfect. Now when we have, like, you know, these controls created, let's go ahead and add them into our view. So what we're gonna do is we're gonna go into our setup view. Okay, and right under slider stop, you're gonna say slider view dot add subview slider text and slider view dot add subview slider shimmer. All right, now for the slider shimmer, we're gonna say the content view for this one is gonna be the slider text. This is how you actually provide that which view is gonna shimmer, and slider shimmer dot is shimmering, set this to true. Okay, all right, so that is the setup for the view. Next we're gonna actually set the slider text constraints. So right underneath slider text, and as layout constraint dot activate slider text dot center x anchor dot constraint equal to slider view dot center x, and I'm gonna copy that and paste it, and this is gonna be center y. and center Y. Okay, so that's gonna be our slider text. Okay, and we're also gonna set the constraints for our shimmer. Okay, and this one is going to be slider. Slider shimmer dot leading anchor dot constraint equal to, and we're gonna say slider view dot leading anchor. Constant is gonna be 75 points from the start, because I want to center that, and I want to start the shimmer right where the text is. So leading trailing anchor dot constraint. Actually, we don't need trailing. We just gonna say slider. Sorry, we need trailing constraint equal to slider view dot trailing anchor negative 75, and slider shimmer dot top anchor is gonna be constrained to slider view dot top anchor, and slider shimmer dot bottom anchor is gonna be constrained to slider view dot bottom anchor, like so. Okay, let's go ahead and give it a go to see if we have our shimmer text. There you go. So shimmering text is showing up, and you can see, like, a slight shimmer right there with a pause, and you can adjust, like, however you want to. For example, you can give the pause duration maybe like 2 seconds. Oh, let's do 1 second and see how that looks. I think it's gonna, yeah, that's way too fast. Let's try 2. Yeah, that's perfect. 2 is actually better. Okay, so we're gonna give it 2 seconds of pause duration. Okay, so we have our shimmer effect set, and we have our slider control working. Now what we need to do is we need to make sure that whenever we are stopping, we are gonna save the new run. Okay, so let's go ahead and work on that. Okay, so what we're gonna do is I guess first thing, let's go ahead and check it out, like where we are stopping. So we are, like, first of all, we need to have a location. So we have a location manager, but in these variables we are not collecting, like, the locations. And if you recall, in the run, in order to add run, we need location, list of location as well. Okay, so what we're going to do is we are going to add a new private or file private variable. File private because we're gonna access this one inside the extension. So file private dot file private var chord locations is equal to list of location. Okay, and what we're going to do is at the extension where we are actually getting the run, wherever we are actually getting the new distance, right here, after adding the distance basically to the location, we are also gonna add a new location, or create a variable for new location. Create a location, and this location takes lat long, so we're gonna say take the double value, extract the double value from end location dot coordinate dot latitude. Okay, and for the long, we're gonna do the same thing. We're gonna say end location dot coordinate, which is geolocation coordinate 2D dot longitude. Okay, so this is going to basically create our location object, and we're going to take chord locations, and we're going to insert that location, new location, at the index 0. So we're going to keep appending it like at the beginning. Okay, and remaining everything else is gonna stay the same. What we are doing is simply adding our location into a local variable, because this is gonna make it easy for us to basically save the run. So whenever we are calling the stop run right here, we're gonna say run dot add run to realm, and here we are gonna supply pace. We are already computing and saving pace inside a local variable. Run distance. Okay, duration is the time elapsed, and chord locations. All right, so these are going to be all things that we're going to be saving, and that's all it should take to basically get save the run inside the realm. Okay, now before we go, let's make another function, and I want to make a function basically for that slider bounce animation. So we're going to say private func slider bounce animation. Okay, and we're going to say UI view dot animate, and we want to take the one that takes duration and completion. So duration, animation, and completion. So duration for the first one is going to be 0.5. The animation is going to be self dot stop slider knob dot center dot x. So we're going to move the center x point by 100 points. So x coordinate, basically move this slider in x coordinate by 100 points. Whenever the completion is done, we're gonna call another UI view dot animate, and this time we're gonna use the one that actually has initial spring velocity and spring with damping. So so let's see, yeah, spring with damping. Okay, so this animation is gonna run for 1 minute. There is gonna be a 0.1, not 1 minute, 1 second, 0.1 second of delay. Initial spring with damping size is gonna be 0.5. It's basically the value how springy you want your animation to be. For the options, we're gonna say curve, ease, in and out, and for the animation itself, we're gonna say self dot stop slider knob dot center dot x minus equal 100. Okay, for the completion, we're just gonna leave it as is, because we don't need anything inside this. So I'm just gonna do it like that. Okay, there we go. All right, so now we want to call this whenever the view appears. Now you can display this like every single time user lands. For example, I'm doing that, but if you want to just display it once, save like a value inside your user default. If user has already seen the bounce, then just don't show it, otherwise play the slider bounce. But I'm gonna leave it like for every single view did appear. All right, so let's go ahead and give it a go. I'm gonna click on run, and there we go. Our animation works fine. So I'm gonna let it run a bit and then gonna stop. Okay, and realm is created, and it has created a log, and we cannot do anything with the selection right now. And as you can see, it's 0.02 is what we are getting. So let me go inside our history table view cell, and instead of 01 we want to say 0.2f. so show after two decimals, like two decimals. So in the log 0.02. There you go, that's better. So what I'm going to do is I'm going to let this run for a few, and then we're gonna save this basically value. Okay, so till that time what we can do is we can go and work on our previous run detail view controller. All right, so I'm gonna simply add a new file here inside the view controller. I'm gonna call this previous run detail view controller. Right, import from UIKit, final class. Base view controller. All right, so this is gonna be our previous run of view controller, and we're gonna take run as an object, like as a parameter, and let's create some UI elements. Let's create a map view. Before we do that, import mapkit. We're gonna set ourselves for the delegate, and don't forget to set the translate to false. Let me put this second. There we go. Okay, we're gonna create a top handle. So top handle, first background. This is gonna be a UI view. Background color is going to be UI color dot black dot width alpha component 0.4. For that, for the top handle, we're going to create a top handle, which is once again going to be UI view. Background color is going to be UI color dot white dot width alpha component 0.6. V dot layer dot corner radius is going to be 3. Layer dot masks to bounds is going to be true. Right, and that's going to be our top handle, the one that we're gonna scroll. All right, then let's create our initializer. So we're gonna create our initializer that would expect a run. So we're gonna say self dot run is equal to the run that's been passed to us, and we're gonna call super dot init with nib name nil bundle nil. Okay, now this is gonna make us basically implement this required as well, which we're gonna leave it as is because this is not gonna be called from the storyboard, so we don't care about this one. Now let's say empty for life cycle. and lifecycle basically events are going to be view did load, super dot view did load, and we're going to call setup views, setup constraints into this, and let's create these functions. By the way, if you wanna do multi-line typing, just hold Option key and drag up. So once again, hold Option key, drag up, start typing private func, and there you go, and hit escape to get out of that multi-line editing mode. All right, so that is our setup view. We can have view did appear, super dot view did appear, animated. Okay, we're gonna set the overlay here. So map overlay is gonna be called here. Okay, now let's create MD for helpers. All right, and here we're gonna first add our subviews. So add subview map view, add subview top handle background, and top handle background dot add subview top handle. Okay, for the constraint, we're gonna first set the constraint for map view. View dot leading, so we're gonna make it cover the whole screen. So trailing top bottom, trailing anchor, top anchor, and bottom anchor. Okay, that's our map view. Then we're gonna set the handle, the top handle to drag the view down, and that's gonna be top handle background. Okay, and let's layout constraint dot activate top handle background dot leading anchor dot constraint equal to view dot leading anchor. Trailing, and we're gonna set the top as well, top anchor dot constraint view dot top anchor. And then for the bottom, we're not gonna have the bottom for this one, we're just gonna have the height. So we're gonna say height anchor dot constraint equal to constant, and we're gonna give it a 20 points of height. Okay, all right, map view does not have bottom anchor. There you go. Okay, then top handle, and as layout constraint dot activate. All right, so this one is going to be top handle dot width anchor dot constraint equal to constant 100, top handle dot height anchor dot constraint is equal to 6, top handle dot center y constraint is gonna be equal to top handle background dot center y, and similarly we're gonna have it for center x. So we're gonna center this inside our handle background view like so. Okay, all right, so now there are a few things that we're gonna do for the map. Okay, so let's see, equal to constant There we go. Okay, so let me take a look at the distance. So we have run 1.3 miles as good, so we're gonna stop that now. Okay, and let's go ahead and take a look. Okay, so our view is not refreshing. That means in the history view we need to, on the view did load, or view did appear, actually view did appear, super dot view did appear animated. We're gonna call table view dot reload data, because we need to, oh yeah, so I'm gonna actually remove this for now because we're gonna come back to this. Okay, so let me go ahead and rerun this, and let's go ahead and start. Oh, I shouldn't. Okay, there we go. So 1.3 right there, and 1.33 is the distance that we have traveled. So that's perfect. Now we have all of our data being stored. Now in the next video, what we're going to do is we're going to continue working on our previous run detail view controller, and add the map view layer and stuff like that, and then just bind it to our detail view and launch it so we can see that run detail from the log. Okay, so that's coming up next. Hello, welcome back, and in this video we're going to be finishing up our previous run detail view controller and hopefully the app. Okay, so while running I actually encountered a bug that we have introduced accidentally, which is look at the time. The run duration has been saved as 0, and I actually found out why. Because we are calling the add run to realm right here when we actually stop the run, right? So we have two choices. Either we stop run after adding it to the realm, or we stop run, we call stop run, and before that we actually cache that time elapsed, like so. Okay, this way the value is cached, and we are not introducing that bug. Okay, so let me go ahead and give it a go, and still it's gonna be 0 because we haven't saved that information. So what I'm going to do is I'm going to once again let it run while we are working on the run detail view controller, and then we're going to come back and basically save it and see if that actually solved the problem. Okay, so where we left off was first of all, this was delegate self. Okay, because I want to add some extensions to it. So let's create MD extensions and extension to previous, and this is gonna be map view delegate. Okay, and the first one that we're gonna actually do, the function that we're gonna call is going to be render renderer for overlay. Okay, this is going to be called whenever we are actually drawing an overlay, and we are going to draw a line. So we're going to create a polyline. So polyline overlay as mk polyline. Okay, and we're gonna get the renderer from mk polyline renderer by supplying the polyline. Right, we're gonna call renderer dot stroke color to be UI color dot blue, and renderer dot line width is gonna be 4 points. We're gonna return this renderer. Okay, so that's going to be first function. Second function is going to be view for annotation. So view for annotation, and we're going to be dropping some annotations basically for start and end point. So let's go ahead and create that. So we're going to say guard annotation is mk point annotation. We're creating a point annotation, otherwise we're going to return nil. Okay, and this is how you actually drop those pins. We're going to create an identifier. Map annotation. Annotation view is map view dot dq with identifier as mk pin annotation view. Okay, now if the annotation view is nil, okay, then we're gonna create our annotation view by creating mk pin annotation view with annotation and reuse identifier. Okay, and we're gonna say annotation view dot can show callout is equal to true. Else we're gonna say annotation view as annotation, sorry, not as dot annotation is equal to annotation. That means we actually were able to DQ one successfully, so we're gonna that's why we are actually gonna sort of like, you know, assign the annotation. We're gonna say if annotation dot title, and this is gonna come just in a bit. We're gonna add these titles, but if the title is start, then take the annotation view and set the pin tint color to be UI color dot red for the start location. Else if annotation dot title is equal to finish, in that case take the annotation view, set the pin color to be UI color dot green. All right, so that's going to convert our pins, and we're going to return our annotation view like so. All right, so those are going to be two functions that we're going to be relying on for our map view, like, you know, from the map kit, and we're going to create some internal functions. So first of all, there's going to be a function that we're going to call set map overlay. So we're going to draw an overlay on the map. Okay, so we're going to create that function right here inside helpers private func. All right, so we're going to say if map view currently has overlays count greater than 0. So if there are overlays in the map view, remove all the map views, remove overlays, map view dot overlays, so remove all of them. Okay, then add overlay onto the map view. We're gonna get the polyline. Okay, so we're gonna create a function called get polyline, and we're gonna get the polyline from run. Okay, so let's go ahead and create that private func get polyline from run. This is going to return mk polyline. Okay, so basically what we're going to do is we're going to draw the polylines on the coordinates. So first thing we're going to do is we're going to get the coordinates from so create a an array of CL location coordinate 2D. Okay, and for each location in run.locations, we are going to simply take our chord and append CL location coordinate 2D with latitude and longitude, and latitude and longitudes are going to come from location, current location, the currently iterating variable of location, location dot longitude, like that. Okay, so this is going to basically give us, this is going to be UR. Okay, this is going to give us the all the coordinates. Okay, and we're going to return mk polyline from this, and mk polyline takes the coordinates. So we're going to pass our chord and chord run dot locations dot count as the count for the polyline coordinates. Okay, all right, so we're going to call we're going to add the overlay. Okay, after adding the overlay, we want to set the map view dot region, set region. This is going to basically zoom in our camera, or like the map view in like above, right above the 2 points. Okay, so before we actually do that, we want to, instead of like pointing it to one location, we want to make sure our map view is zoomed enough that it can show both points in the map. Okay, for that we need a function which is going to center our map. Okay, so we're gonna call that one center map. Okay, and this is gonna expect a run, so we're gonna say run animated true. Okay, and basically what this function is going to do is it's gonna center our map on those 2 points. So we're gonna create a private function, center map run. Okay, and this is going to give us mk coordinate region. Okay, now this error should be gone. Okay, there we go. All right, so let's finish this part, and then we're gonna come back and set this set this center map up. Okay, now we're gonna get the start point, mk point annotation. Okay, start point dot title is going to be start. Now this is the same start that we are actually trying to match here, so we can color our pin. Okay, so we're going to set the title here to be start. Start point dot coordinate is gonna be CL location coordinate 2D. Okay, for the latitude and longitude, we are going to basically get the location. So let location is equal to run dot locations, and we're gonna get the last index. So run dot locations dot count minus 1. Now you must be thinking, why last? Because we are inserting every time whenever we are recording a like a coordinate, we are inserting that at the index 0. That means the start point is going to be the very last element inside the array. Okay, so that's why we are getting the last point, and we're gonna say loc loc dot latitude and location dot longitude, like that. Okay, so this is gonna give us the start point. We're gonna take our map view and we're gonna say add annotation to this map view at the start point. Okay, similarly we're gonna create our end point. So I'm gonna copy this, paste it. I'm gonna call this end point, endpoint, endpoint, and endpoint. Okay, so we're gonna call the endpoint's title to be finish. Okay, we don't need this. Actually, we're gonna say start location. Okay, so I'm gonna change that to start location, and this is gonna be end location, and this is the 0th index. That's where we ended. So end lock, end location. Okay, and we're gonna add the endpoint. All right, inside the map. So that's setting up our overlay. So we have set the overlay just right. Now let's go ahead and fix this error. Now in order to get the center map, we need to get the min and max location coordinates. So I'm going to create a private function, get min max location coordinate. Basically we're going to get the run and find out the minimum and maximum between those, and this is going to return a tuple with min CL location coordinate 2D and max CL location coordinate 2D. Okay, and this is basically going to be an optional. All right, so we're going to first say let locations is equal to run dot locations. Okay, guard let first location. If we can get the first location from locations, otherwise return nil. Okay, I'm gonna say min lat var min latitude, like the minimum latitude inside, is equal to first location dot latitude, or min long is equal to first location dot longitude. Max lat is equal to first location dot latitude, or you can actually simplify this by saying min lat, or max long is min long. Okay, these are variables. Now we're gonna iterate over each location in locations. Okay, and we're gonna get the min max. Okay, so min lat is equal to min between min lat and location dot latitude. Min long is min between min longitude and location dot longitude. Okay, same for max latitude, max of max latitude and location dot latitude. Max long is max of max long location dot longitude. Okay, so we're gonna get the min max from this, and we're gonna simply return min as CL location coordinate 2D with latitude as min lat and min long for the latitude and longitude. For the max, we're gonna say CL location coordinate 2D. Once again, max lat, max long, like that. Okay, so that's gonna give us the min and max, minimum and maximum of the longitude and latitude, and then we're gonna center our map. So we're gonna first put a guard statement here. I'm gonna say guard let min location and max location. Can we find out those from get min max location, supplying the run? If we can get that, good. Otherwise, mk coordinate regions, just supply that an empty initializer. Okay, if we can find those, we're gonna create mk coordinate region, all right, with center latitude and longitude in span. Okay, so center takes CL location coordinate, and we're gonna say for the latitude and longitude we're gonna take min location block dot latitude plus max block dot latitude, and we're gonna divide this by 2. Okay, and for the longitude we're gonna do the same thing, so divide by 2. This is gonna be min longitude, min log dot longitude plus max location dot longitude. Okay, so minimum location dot latitude plus maximum location dot latitude, and minimum location dot longitude plus maximum location dot longitude. Divide by 2. It's gonna give us the oh, this is at the wrong place. Oh wait, I was right. Okay, and this is basically gonna give us the center point for the location coordinate 2D, and for the span we're gonna create mk coordinate span, and this takes longitude and latitude delta. All right, so this part is in degree. So what we're gonna do is we're gonna basically take our max latitude, so max location dot latitude minus min location dot latitude. We're gonna basically subtract that, and we're gonna say times 1.5. This is how much zoom you want, basically. That's why we are computing here. And same, this is gonna be max location dot longitude minus min location dot longitude times 1.5. Okay, so 1.5 times is what we wanna zoom in. All right, with that, our previous run detail is done, and let's go into our history view controller, and we want to make a call to this one and see if we can actually display that. So let vc is equal to previous run detail view controller, pass it the run, and we're gonna present the run or vc animated true, completion nil. Okay, let's go ahead and oops, okay, I made a mistake. I directly launched it without saving, so that's okay. All right, so I'm gonna let it run and pause the video and basically resume when it has enough run. All right, so our run is almost a quarter to a mile, so I'm gonna just stop this now and go ahead and save that inside the realm. So there we go, 0.26. That's perfect. So I'm gonna just click on it, and there we go. As you can see, our zoom is working, and this is our finish point, and this was our starting point, and this is our little handle to swipe down. And if you notice, like you cannot swipe anywhere because our map is actually covering the entire screen. That's why we created this handle so user can swipe down from here. Okay, now there's one more thing that I want to do, like, basically if you notice, this screen is selected, or like, this view remains selected. So this is easily fixable. So right before this, before launching the run, we're gonna say table view dot deselect a row at index path animated true. All right, so this is going to essentially launch, and we're gonna go into the logs, gonna go, and there you go, like, our time is also being saved. There you go, so our bug is fixed. I did not realize this bug was actually there in the original app as well, like, the one that I created before creating this one. So but yeah, so there we go, this is our run. Let's go ahead and take a look at another run, 1.3 mile. So this was the 1.3 mile, and this is the run that it actually covered. So it started here and ended right here. Okay. All right, and as you can see, our T select is gone. Just take a look at it one more time. It looks like everything is looking good. All right, so with that, you have reached the end of this video course, and I hope you had fun and learned a whole bunch about view controllers, map views, core locations, and stuff like that. So yeah, so thanks again for watching, and I will see you guys in another video series. Thank you.